Welcome to class today, pre-calculus students. Hope you guys are doing well today. Good to see you guys yesterday in class. I hope I hope Caleb did well on his test. Caleb, I've not graded that test yet. And the rest of you young men, I hope you're finishing it. I hope you finished it yesterday. If not, I hope you'll finish that by today, Tuesday. But it is due by Friday. So here's some quick announcements. Again, guys, care about y'all. I want to give you a great math class, but we've got to keep things accurate when it comes to deadlines. So make sure you're working on that test. The latest I'll take it is this Friday, okay? All right, announcement number one, we will have a quiz this Friday, and to be honest with you, we could actually change that and make that, sorry about that, let me get my black ink up here. There we go, and there we go. Actually, I should say Saturday because that's when you always take it. I always email it to you late Friday night or Saturday morning, but you'll have a quiz this coming weekend. Next announcement, those that still owe me a test, don't forget, no later than Friday. I prefer you get it done in the next day or two for your own sake, but you don't have to. So test due by Friday. Integrity sheets, I think there were 2 that were supposed to contact me. I don't have that folder in front of me. I will be looking at grading some stuff later, and I'll give more specifics in the next video, but you know who you are if you were supposed to contact me on this, so don't forget to do that. And I think that's all the announcements. Yes. Okay, pause the video if you need to. Go get your notebook, get your math book, get your brains, get your pencils, get your calculators. And let's get ready to have some fun and learn some trigonometry. Here we go. Okay, our heading today is solving right triangles. Solving right triangles. The lesson number is 5.2. And if you are one that keeps the date, which I recommend that you do, today is the 10th. 9/10. And what year is it? 2013. All right. Solving right triangles. All right. Copy that down, please. I'm going to go fast. Pause the video as you need to. Now, there's something you need to know. When I say solving a triangle, that means that we're going to find the measurement of all 6 parts. Now, you might say, Mr. Earhart, what do you mean 6 parts? Well, are there not 3 sides to a triangle? Sure. Are there not 3 angles? Sure. So when I say we're going to solve a triangle, that means that we are going to find the measurement of all 6 parts, which is the 3 sides and the 3 angles. In this section today, we will be solving right triangles only. Okay? Right triangles only. So with that in mind, let's go ahead and look at our first problem to give you some closure. Actually, today's video might be relatively short. We're going to look at 3 problems and then let you get started on your homework. Men, go ahead and copy this triangle into your notes. Notice this side here is 106.2. This angle down here is 61.7 degrees. And of course we have a right angle, thus we have a right triangle. Now, of course, if I go too fast, pause the video and copy this down. I would like to point out to you from now on, unless otherwise stated, whenever an angle in a triangle, well, let me not say whenever, angles in triangles are going to be denoted by a capital letter. So see how this angle right here is capital A? Do you notice how if you go directly across, it's a little a? Do you see up here how we have capital B for this angle? If you go straight across, it's a little b. Do you notice how we have capital C for this angle here? And if you go straight across to this side right here is called little c. We're going to use that denotation from now on. Look at the next example real quick. Don't copy this down, but look, here's a capital E for this angle, so this side over here is called little e. Here's capital D for this angle, so the side over here is little d. This is capital F right here, so the side across from that is little f. We're going to do that from now on unless otherwise stated. So do get used to that and understand that's not a coincidence. That's very normal in trigonometry. Okay, let's go ahead and solve this triangle. I've asked you to copy this down. I'm going to circle what we know. We know one side. We do not know this side. We do not know this side, the measurement. We know 2 angles. We know this angle and this angle. We do not know this angle. So we're missing 3 parts. Do you see what I'm saying? In order to solve this triangle, we're missing 3 parts. An angle, a side, and a side. Okay? Now I'd like you to write this sentence down. It's a very important sentence. Let me get my eraser. I got it hidden here. Okay, I'd like you to write this in your notes. When you know 2 angles, like we do in this problem, look, we know 2 angles. We know this angle and we know this angle. when you know two angles, find the third angle first. That's the first thing you do. Got it? Let me go over that again. When you know two angles, find the third angle first, okay? Now, Matthew, you've not had geometry. Understand that anytime you add up all three angles inside of a triangle, the sum always has to add up to 180 degrees. So it's going to be really easy to find this angle right here. We know one angle is 90 right here. We know one angle is 61.7 right here. So with your calculators, if you add those two angles together, you will get 151.7. Okay? So how do I find this third angle? Well, I simply subtract it from 180, right? I mean, if all three angles have to add up to 180, and I know these two here add up to 151.7, then subtract it from 180, and use a calculator, of course, that's totally fine. I'm going to do mine longhand here. I don't have a calculator with me. 7, 10, 9, that would be a 3, this would be an 8, and that would be a 2. So if you subtracted correctly, you will get 28.3. So I'm going to write that in red so I know that's one of the angles I just found. I just found angle B, 28.3 degrees. And I'm also going to write that right here, okay, guys? So measure angle B, 28.3. And guess what? Now it's about ready to get super hard. So I hope you'll listen. Don't get scared. Listen and really pay attention, okay? We're missing two sides, okay? Now, we're going to use sine, cosine, and tangent, our trig ratios, to help us find these missing sides. Let me say that again. We're going to use sine, cosine, and tangent to help us find these missing sides right here, okay? Now, it really does not matter what angle you use. Got it? It does not matter what angle you use. Now I'm just choosing to use this angle down here. There's no reason for that. That's just how my notes are set up. So I'm going to use this angle right here. All right. Now, based on this angle, okay, go straight across. This is now my opposite side. This is my hypotenuse side. Everybody see that? And this is my adjacent side. That's pretty easy. Mr. Earhart, what if I would have chose this angle up here? No problem. No problem. That would totally work, okay? But in this case, I've chosen to use this angle. No certain reason. Now, never when we write an equation do we want two unknowns, right? Why would I want an x and a y? That makes no... let me show you what I mean. For example, watch this, okay? See this angle right here? If I wrote... Now watch this, guys. Just sit back and watch. If I wrote tangent of 61.7... What's the tangent of 61.7? Opposite over adjacent. TOA, SOHCAHTOA, opposite over adjacent. Well, that would be A over B, because I don't know the opposite side, so I would have to put in A. I don't know the adjacent side, so I'd have to put a B. And look what you have. You have an equation that has how many unknowns? 2. I don't want an equation with 2 unknowns, so don't use tangent. Do you see what I'm saying? Don't use a trig function that gives you 2 unknowns. However, if I use sine, watch this. Sine of 61.7 equals what? Well, let's see. Sine is opposite over hypotenuse. Opposite is A. Hypotenuse is 106.2. Now we're talking. Look at that, guys. Now we're talking. Okay, that makes a lot more sense. I have one unknown. Mr. Earhart, could have you used cosine? Yes, you could have. You actually could have used cosine. You could have said cosine of 61.7 equals adjacent over hypotenuse. Why didn't I? No certain reason. No reason at all. I just chose to use sine. You could use cosine and you would be totally fine. As long as you just have one unknown in your equation, you're totally fine. Now, watch. Here's where some algebra principles come in, okay? I don't like this fraction, and if I want to get rid of a fraction, I multiply both sides by the bottom, or the denominator. So, I don't want this fraction here. The bottom is 106.2, so I'm going to multiply this side by 106.2. But if I multiply one side by 106.2, I must also multiply the other side. Now, why did I do that? Well, I'm glad you asked. Here's why. See how these two sides, if I take A over 106.2 times 106.2 over 1 these cancel, and I'm left with just A, and that's what I wanted. And down here, I'm left with 106.2 sine 61.7 degrees. So now you know what A equals. It equals this. Did you know with your calculator you could type this whole thing into your screen right now and we're finished with A? Are you ready? Go ahead and get out your calculators. Now make sure you're in the degree mode, and if you're in the degree mode, type in 106.2 and then hit the sign button, then hit 61.7. Don't worry about the degree symbol, you're already in degrees. Let me go over that again. Type in 106.2 and then hit sign, and then hit 61.7. So this whole thing should be on your screen. Then hit enter, and you should get this right here. If you're doing it correctly, you should get 93.5. So now I know what A is. I'm going to come over here and write it in red. Right here, I now know that A is 93.5. So I'm going to come up here and write A, little a. That means little a means it's a side. Side A is 93.5. All right. Now, in order for us to solve this triangle, we're missing one more piece of the puzzle. We are, Mr. Hart? Yeah. We know our three angles. I'm going to put check marks. We know 1, 2, 3 angles. We know our three angles. We know two sides, this side and this side, but we have never found the measurement of B. Now I have a question for you scholars, okay? Listen. I have a right triangle, correct? Sure. And I know how many sides? 2. Why not use Pythagorean's theorem? Matthew, you and I looked at that a lot during that review sheet day. Look, use Pythagorean's theorem. I mean, if you know two sides of a right triangle, find the third side. Remember, it's a leg squared plus a leg squared equals the hypotenuse squared. So one of your legs is 93.5. So put 93.5. The other leg we don't know, so we're going to call it B. B squared. The hypotenuse is 106.2. Sounds like a radio station, doesn't it? 93.5 squared, 106.2 squared. Now, if you type in 93.5 squared, right here you'll get a really big number. It's going to be 8,742.25 plus B squared. And if you type in 106.2 squared, you're going to get 11,278. 11,278.44. Now, simply take this 8,000 number over, bring it over, and make it a negative number. And when you do that, you'll have negative 8,742.25. Of course, it's gone from over here, so you're left with B squared equals 2,566.19. And now take the square root of both sides. And when you take the square root of this side over here, you will get 50.4 if you're doing everything correctly. Now I'm rounding all of these. I think you know that I'm rounding all these. So I come right here in red. 50.4 is this side. So I'm going to come up here and put side B is 50.4. There, we solved a triangle. Don't forget this. Young men, please look. When you know two angles, the first thing you do is you find the third angle. Please don't forget that. That'll be really helpful when you're solving these triangles. Okay, next to last problem. One more after this and we're finished. And I've only given you 150 of these for your homework, so you'll be totally fine. Go ahead and copy this in your homework, please. And we're going to solve this right triangle. Go ahead and copy this in your notes. Again, if you got to pause the video, I'm going to go ahead and move on. There's a sentence I'd like you to write in your notes, and here it is. When you know two sides, find the third side first. Now I'm going to go ahead and add something. I should have typed this. By Pythagorean's theorem. So if you know two sides, the first thing you want to do is, just like if you know two angles, you find the third angle by adding them up and subtracting from 180. Well, if you know two sides, I want you to find the third side by using Pythagorean's theorem. So here we go. L squared plus L squared equals H squared. One leg is 13. The other leg is D. The hypotenuse is 23. If you square 13, you get 169. And if you square 23, you will get 529. And now bring this 169 over and make it a negative 169. And when you do that, this is gone, and you're left with d squared equals 360. And then take the square root of both sides, and you will get, let me look in my notes here, 19. Of course, I'm rounding, but 19. So side d right here equals 19. So d equals 19. There we go. Now all we have to do is find two angles, right? I mean, I know all three sides. I know one angle right here is 90. All that I have to do now is find a missing angle. Now, did you write this down? When you know two sides, find the third side first. I want to give you another note, and I cannot stress to you how important this is. When you only know one angle, like here, we only know one angle, okay? When you only know one angle, always solve for the smallest angle first. Please don't forget that, students. I cannot express to you how important that is, especially when we get to oblique triangles that have obtuse angles in them. When you only know one angle in a right triangle, solve for the smallest angle first. Always, always. Now don't forget, if we knew two angles, we could do what we did back here, in which we add the two angles up and then subtract it from 180. We cannot do that here, so we're going to have to use sine, cosine, or tangent. Let me say that again. We're going to have to use sine, cosine, or tangent to solve for one of these missing angles. Now, students, what did I just tell you to copy down? When you know only one angle, solve for the smallest angle first. But here's the problem. How do I know if this angle here is the smallest one or this one? Well, I'm glad you asked that question. The smallest angle is always across from the smallest side, okay? So I've got a 13 here, a 19 here, and a 23 here. Obviously, what's the smallest number? 13. So if this is the smallest side, then go straight across to that angle over there, and that's the smallest angle. Isn't that cool? Let's go over that again. The smallest angle is always across from the smallest side. So I've got a side of 13, 19, and 23. Out of those three sides, the smallest side is 13. So I go straight across to this angle here, and that is the smallest angle. So students, this is the angle I want to solve for first right here. So I don't know why I erased it and put it back up there. This is the angle we're dealing with, angle F. So I'm going to go straight across. This is called my what side? Opposite. Here's my right angle. This is called your hypotenuse. And the only side left is called your adjacent side. All right. Now, it really doesn't matter here what trig function you use. We can use sine, cosine, or tangent to solve for f. In my notes, I just chose to use sine. Now watch what happens. Sine of f equals what? Opposite, which is 13, over adjacent, which is 19. Excuse me, that's a mistake, and I apologize. Sine is opposite over hypotenuse, so it would be 13 over 23. Now, let's stop right there. Everybody listening? Let's go back to the previous problem. And if you'll look in your notes, okay, if you'll look in your notes, you will see that the equation you used here was this. Look in your notes and you'll see it. You said sine of 61.7 is A over 106.2. Look in your notes and find that. Does everybody see that problem? Okay. The A, the unknown, was it over here in the fraction, or was it here where the angle is? Well, it was over here in the fraction, wasn't it? Here's your unknown, and it was in the fraction. Now look at the problem over here that we're doing. Oh, it's a little different. Look at this. My unknown is not in the fraction. It is not. My unknown is the angle. Now remember what to do, guys? If not, we're going to go over it again right now. Anytime you're missing an angle and you want to solve for an angle, you hit second sine, and when you hit second sine, this is what pops up on your screen. So go ahead and do that. Hit second sine, and it should say sine to the negative 1 parentheses. And then you type in 13 divided by 23, and then hit enter. And up will pop angle F. So are you seeing when to use this this sign to the -1? When you're looking for an angle, and I'm looking for an angle. Now, if you hit second sign and this pops up and then type in 13 divided by 23 and hit enter, you will get 34.4 degrees. F equals 34.4 degrees. So I'm going to come over here and here's F and I'm going to write 34.4. There we go. And now look guys, look. This is a pretty simple problem. Look. Here's a right angle. That's how many degrees? 90. Here's angle F. That's how many degrees? 34.4. Add those two together and you'll get 124.4. And now subtract from 180 because this third angle right here, angle D, has to be an angle that makes all three angles add up to 180. So you know these two angles here add up to 124.4. So I'm going to take 180 and subtract out 124.4. And of course you're welcome to use your calculators, no problem there. Let me check this, see where, yeah, this is right. So you should get 55.6 for angle D. And we're done. One more left and we're finished. Not bad today. So we know all the angles, we know all three sides. Let's quickly review. When you know two angles right off the bat, find the third angle first. When you know two sides right off the bat at the beginning, find the third side by using what? Pythagorean's theorem. And when you only know one angle, always solve for the smallest angle first. Always, always. Very important. Okay? And then here's the last problem. So go ahead and take a second and copy this into your notes, please. All right, let's go ahead and solve this right triangle. Now, notice right away I know two angles, angle 1, angle 2. So you know from this note back here, when you know two angles, find the third angle first. So we're going to take 20.6 and add 90 degrees to that, and we're going to get 110.6, and then we subtract that from 180. Of course, feel free to use your calculator, and we should get this, this, and this, I believe. Yes, 69.4. So now we know angle A is 69.4. Okay, so measure angle A, 69.4 degrees. All right, that was easy enough. Now, think back to the first problem. I told you you've got to choose an angle, and now we're going to use, oh, let me stop right now. Look, guys, if we knew two sides, we'd use Pythagorean's theorem. Do we know two sides? No, we only know one side. So that's why we have to use trig functions, okay? If we knew two sides, we'd use Pythagorean's theorem. Now, it does not matter which angle you use, okay? You can circle this angle or you can circle this angle. I chose in my notes to go with this angle. Doesn't really matter. So I go across. This is my opposite side. Here's my right angle, so this is my hypotenuse side. This is my adjacent side, okay? Now, remember, we don't want equations with two unknowns. That makes no sense, okay? For example, if I were to use sine of 20.6, watch this. Sine of 20.6 equals opposite over hypotenuse. Well, that makes no sense. I've got two unknowns. I don't want to use sine in this problem. That gives me two unknowns. That makes no sense. So let's use something else. In my notes, I used cosine. Now, you could have used tangent also. I just chose cosine. So cosine of 20.6 equals adjacent over hypotenuse, which is C. Now, this is going to be a little different, so please watch carefully. Now, what I told you in this problem that we did earlier is I said I don't like fractions, okay? And I always want to get rid of my fractions. So you always multiply both sides by whatever the bottom is. Now, in this case, the bottom of the fraction is C. So I'm going to multiply this side by C. because that's what the bottom is. But if you multiply one side by c, you've got to multiply the other side by c. So over here, your c's cancel, leaving you with 7.5. Over here, I would have c times cosine 20.6. Now, students, please think about this for a second, would you? I want to get c all by itself, okay? So, if c and cosine are multiplying, would I not now just divide by cosine of 20.6 and divide the other side by cosine of 20.6? Makes total sense to me. These cancel out, and now c is finally all by itself. So I'm left with 7.5 over cosine of 20.6. Now in a second, I'm going to show you how to type that in. I'm probably going to annoy some of you, but so be it. I'm going to very quickly go over this again. Now, please watch. As soon as I wrote this equation, I saw that I had one unknown. I said to myself, okay, self, my denominator, the bottom of the fraction, is c. So I'm going to multiply this side by c, because that's what's in the bottom. But if I multiply one side by c, I've got to multiply the other side by c. I do that so these c's cancel, and I'm left with 7.5. Over here I have c cosine 20.6 degrees. Now I want to get this c all by itself. So it makes sense to me, if the c and the cosine are multiplying, I'm going to divide by the cosine of 20.6, divide cosine 20.6. These cancel, and I'm left with c equals 7.5 over cosine of 20.6. So now, do you want to know what c is? I'm sure you do. Now all you have to do is take your calculator and type into your calculator. Now listen, I'm going to tell you exactly what to type in. You type in 7.5, and when you do, this will appear on your screen. Then hit divide, and this will appear. And you don't need parentheses. Then just type cosine, and when you hit cosine, up will pop cosine with the parentheses. It comes up automatically. And then type in 20.6. Okay, I'm going to go over that again. Type in 7.5, then hit divide, and this will pop up. Then hit cosine, and the little parentheses appears. Type 20.6, close the parentheses, and then hit enter. And if you've typed that in correctly, what you will come up with is 8. Exactly 8. All right? And that's for the length of c. So the length of c is 8. Now let's see what we've got. We know all three angles. That's good. We're missing one side. Hey, if we know two sides in a right triangle, let's use Pythagorean's theorem. That's the best way to do it. L squared plus L squared equals 8 squared. So I'm missing this side right here. That's a leg, so I'm missing a leg. So we'll say leg squared. Actually, we're going to call it b because it is b. So b squared plus my other leg is 7.5, so 7.5 squared. My hypotenuse is 8, so 8 squared. Now, if you type into your calculator 7.5 squared, you should get out 56.25. And of course, if you type in 8 times 8, you'll get 64. Now, bring this 56.25 over and make it negative. And when you do, you're left with b squared equals 7.75, and then take the square root of both sides, and b does equal approximately 2.8. 2.8. All right, so there we go, 2.8, and that's it. Now guys, listen to me. Call me, email me. You need to do that every day if you have to get your questions answered. That's what I'm here for. Don't be embarrassed about that. Please do your homework. I've given you 10 of these. That's not bad. A lot of teachers would give 15 or 20. I've given you 6. Actually, I think it's 11, 10 or 11. But here's your assignment, page 454, numbers 1 through 6, and numbers 7 through 15 odd. This is where you practice. This is where you get better. And this is where you learn whether you really know the stuff well or not. Okay? So please work on your homework. Use the help video if you need to.